In this video, we're going to address a really important question, which is, can we use the x-intercepts to find the vertical stretch in factored form? So in order to sort of investigate this question, let's use an example. So here's the example. A parabola has x-intercepts -1 and 7. Can you find the vertical stretch? So if we're given the x-intercepts, we can easily write this into factored form. So let's write it into factored form. So we have y equals a, and since we have the x-intercepts -1 and 7, this is going to be x plus 1, and it's going to be x minus 7. So let's investigate. So the coordinate for -1, or the x-intercept of -1, is -1, 0, and the coordinate for 7 is 7, 0. It's the x-intercept, so x is equal to 7 and y is 0. And remember, when you have the x-intercept, y is always 0. And here the x equals -1 and the y is 0. Okay, so let's plug this in and see if we can figure this out. So here y is equal to 0, so 0 equals a. And here the x is -1, so -1 plus 1 and -1 minus 7. So 0 is equal to a. -1 plus 1 is 0, and -1 minus 7 is -8, right? So 0 is equal to basically -8a times 0. And what is anything times 0? Anything times 0 is equal to 0. So 0 equals 0, which is true, of course. 0 has to equal to itself, but we have not been able to find what a is. So in other words, we could not find the vertical stretch. Now let's try it with the other coordinate. Maybe we might get lucky with the other coordinate, so let's just see. So once again, y is equal to a, x, let me just scroll up a little bit, yeah. So x plus 1, x minus 7. So let's plug in this point. Here's the x, here's the y. So 0 is equal to a, this time x is 7, so 7 plus 1 and 7 minus 7. So here we go, 0 is equal to a, this is equal to 8, and 7 minus 7 is 0, so 0 is equal to 8a times 0. And what's anything times 0? Well, it's obviously equal to 0. So that's true once again, 0 is equal to 0, but we have not been able to find what a is. So in this case, when we were in factored form, remember the question was, can we use the x-intercepts to find the vertical stretch in factored form? Here was our factored form. We plugged in the x-intercepts and we could not find what the vertical stretch is. So the question is, well, obviously we can see that we cannot use the x-intercepts, but let's look at why. Why can't we use the x-intercepts to figure out what the vertical stretch is in factored form? So let's take a look at the same equation, y equals a x plus 1, and let's sort of draw it out and see what that looks like. So here we have our x-intercepts, which is, remember, this is x plus 1, and when you set y to 0, it becomes x equals -1, so here's -1. And this is x minus 7, when you set y equals 0, it'll become x equals 7, right? And if we want to find out the axis of symmetry, remember the axis of symmetry, oops, ry, it's not the best. Do that again, symmetry. Right? Remember, x equals p plus q divided by 2. And remember, p and q are the x-intercepts. So it's -1 and 7. So it's equal to -1 plus 7 divided by 2. So it's equal to 6 divided by 2, which is equal to 3. So 3, let's just say, is right here. And we have our axis of symmetry right there. Okay, so remember, our vertex lies on the axis of symmetry. So let's draw one vertex. Let's just say we have our vertex right here, right? We cannot find, if we plug in 3 over here, actually, yeah, let's just see if we can find the vertex. We can see, we take the x coordinate and plug it in right there. So y equals a times 3 plus 1. Remember, this is the x coordinate of the vertex, which is 3. And we're trying to find the y coordinate of the vertex, which is 3 minus 7. And if I scroll down, it's equal to a times 4 times -4, which is equal to -16a. So y is equal to negative 16a, which doesn't really give us a specific answer. It doesn't tell us a y coordinate. It says 16a, and a can be anything. So what that means is we can have multiple vertices. So let's draw them. So say, for example, we have our vertex right there. So this is going to be, this is how this one graph will look like. But what happens if we have a vertex right here? Well, then we'll have another graph that looks like that, and has to go through both these x-intercepts, right? But what happens if we have one over here? Well, then it has to go something like this, right? And what happens if we have another vertex right here? Well, then it'll go something like this. So what it tells us is that our vertical stretch can keep changing. If we have it in this form, we can have any vertical stretch that we want. So in other words, can we specifically use the x-intercepts to find the vertical stretch? No, because we can have multiple vertical stretches, and depending on what the vertical stretch is, it will look like a totally different graph. It will still go through these x-intercepts, but it will have a completely different graph. So the takeaway here is, here's the takeaway. Here's the takeaway, okay, is that in factored form, right, we cannot use the x-intercepts to find the vertical stretch. Once again, let me read that again. In factored form, we cannot use the x-intercepts to find the vertical stretch. We need another point. And in the next video, I'm going to show you how we can find the vertical stretch using another point. See you in the next video.